Midpoint theorem. The question may be like state and prove midpoint theorem. Okay, એવું હોઈ શકે કે state and prove midpoint theorem આવું આપણે પૂછી શકે. તો સૌથી પહેલા આપણે સ્ટેટમેન્ટ લખવાનું. સ્ટેટમેન્ટ છે line segment joining midpoints of two sides of triangle is parallel to third side. What does this mean? This is line segment. Line segment. This is line D. D is line segment. Okay, D, which I am making it bold. Now D and E are actually midpoints of side AB and AC. D and E are midpoints of sides AB and AC respectively. Now this line segment DE is parallel to BC. This is what we have to prove. So you can take like this, that given in triangle ABC, D and E are midpoints of sides AB and AC respectively. This is what it is given. And to prove, you have to prove that this line segment joining this midpoint, that is DE, is parallel to BC. This is what you have to prove. Now what you have to do is over here, say, let us construct or let us extend this DE. Let us extend this DE to F, DE to F, such that this side DE is equal to EF. DE is equal to EF. We will extend this DE to F such that DE is equal to EF. Now join this C to F. Join this C to F. Now when you join this C to F, you get two triangles, triangle ADE and triangle CEF, right? Now you can see over here that you already have that E is midpoint of AC. So AE is equal to EC. You have constructed that DE is equal to EF. And third side, we do not have any information about AD and CF. But we have this information. These two angles are vertically opposite. These two angles are vertically opposite. So for these two triangles, triangle AED and CEF, we can say that by side, angle, side, these two triangles are congruent. Now, if these two triangles are congruent, what can you say more? You can say if these two triangles are congruent, then you can say that also this CF is equal to AD, corresponding part. Also, you can say that this angle A is equal to angle C. Why? CPCD, corresponding part. Now, they also form alternate angles. You can see this Z. See, I am drawing over here like this Z, or I'll draw it by another color, then you will be able to see it very clearly. Say this red color, it is making a Z, and angle formed by Z are equal. We just proved, right? So if these angles are equal, what can you say? You can say that this AB is parallel to CF, right? This is what you can say. Also, you can say that as D is midpoint of AB, as D is midpoint of AB, AD is equal to BD, right? AD is equal to BD, right? So now AD is equal to BD. AD is also equal to CF. We have proved earlier. AD is also equal to CF. This thing, AD and CF are equal. So you can say that BD, which I am making bold, is equal to CF. So one pair of opposite side is equal. Also, we have proved that this is parallel. Also, we have proved that this AB is parallel to CF. So in quadrilateral BCFD, in this quadrilateral, you can see that BD is equal to CF and BD is parallel to CF. So if one pair of opposite side is parallel and equal, that means it is a parallelogram. That means it is a parallelogram. So BCFD is a parallelogram. Why? For any quadrilateral, if any one pair means BD and CF, this pair is equal also and this pair is parallel also. So if one pair is parallel and equal, it is a parallelogram. Now we know that for parallelogram, opposite sides are equal. So DF is equal to BC, isn't it? Right? But we also know that we have constructed EF such that DE is equal to EF. DE is equal to EF. That means you can say that DE is half of DF, isn't it? This and these are equal. So you can say that DE is half of full DF. Yes. Now DF is equal to BC. So can I replace DF as BC? Yes. So what I got is DF is half of BC, and also I got that as it is a parallelogram, DE is parallel to BC. Now actually midpoint theorem says that line segment joining midpoints of two sides of triangle is parallel to third side and is half of third side. Half of third side. That is, we need to prove, in this case, we need to prove that DE is parallel to BC and DE is half of BC. This is what we need to prove. To prove DE is parallel to BC and DE is half of BC. This is what we have to prove. Okay. So I think you got a rough idea. Now I will again write this and explain this to you. Again, I will write it and explain it to you. So be attentive over here. We will go step by step in this case and prove that this third side is parallel also and they are half of the third side. Now this is D, this is E. I have extended EF such that this and these are equal. Already E is midpoint, so E is equal to C. So in proof, I will be using all this. Here, E is midpoint of AC. This is given. Therefore, AE is equals to CE. I'll give this number 1 because I got this thing. Also, there is one construction, so I'll write construction over here first. Construction. After exactly we write to prove, write construction. So construction is extend, or you can say you can use this word proceed DE to F such that DE is equals to EF. Yes. We have to proceed in such a way. So I can also write that therefore in triangle AED and triangle CEF. Now while writing this triangle, we have to write corresponding parts. I already know that these vertically opposite angles are going to be equal. So here in triangle AED, E is in second place. So over here also I will write E in second place. Also I know that AE equals to C. Here AE is first two side. So C will be also first two side. E we already had written, so I'll write CE. And third it will be F. So this is how we have to prove, right? So in triangle AED and triangle CF, AED and CF, what do we have? One is AE equals to CE from 1. Second is angle AED is equals to angle CEF. Reason vertically opposite angles. This I have written reason also. Opposite angles I have written this reason. And third is, this is what we have constructed, that DE is equals to EF. This is construction. I'll write in proper way. DE is equals to EF and this is construction. Okay, so what we have now? We have three things. Number 1, this is side. These two angles are equal and again these two sides are equal. Therefore, triangle AED is congruent to triangle CEF by SAS congruence. We got this thing. I'll make a proper partition over here so things doesn't get mixed up.
Yes.
Now what? Now see. We got these two triangles congruent. So we can say that therefore this AD is equal to AD means first third. So CF is also first third. So AD is equal to CF. AD is equal to CF. CPCT. I am going to use this. So I am going to give second number. Also I am going to use this angle. So angle DAE is equal to DAE. Now DAE like this. 3, 1, 2. So 3, 1, 2. That will be FCE. Right? FCE. Okay. So angle DAE is equal to angle FCE. Give this number 3. Also this is CPCT. Now as these two angles are equal, I am showing you in figure. As these two angles are equal and they form pair of alternate angles. Also they form pair of alternate angles. Also they form pair of alternate angles for lines AB. This is AB, right? AB and CF.
Yes.
AB and CF and transversal AC and transversal AC. Therefore, AB is parallel to CF.
Yeah.
That is, you can say BD is parallel to CF. I am going to use this. I'll write this as 4. Also, as I proved that AD is equal to CF, I am showing in figure. But D is midpoint of AB. So AD is also equals to BD. So I'll write also D is midpoint of AB. This is given. Therefore, AD is equals to BD. Take this as number 5. Now AD is equals to BD in number 5. AD is equals to CF in number 2. So from 2 and 5, I can say that BD equals to CF. I'll take another page. Therefore, from 2 and 5, BD is equals to CF.
Yeah.
So we got one, BD is equals to CF. Give this as number 6. Now see, in number 4 we have BD parallel to CF, and in number 6 we got BD equals to CF. So from 4 and 6, BD is parallel to CF.
Yes.
And BD is equals to CF. Therefore, in quadrilateral this BCFD, in quadrilateral BCFD, one pair of opposite side is parallel and equal. Therefore, BCFD is a parallelogram. Now, as this is a parallelogram, both pair of opposite sides are parallel. So I can say that DF is parallel to BC. Therefore, DF is parallel to BC. That is, DE is parallel to BC. That makes this number 7. Why DE? Ray DE is equals to ray DF. They represent same ray. So we can say that they are same line. Okay. Or you can write DE and DF are same line, represent same line. You can write that thing also in reason. Now you got one. D is parallel to BC. Now you need to prove that D is half of BC. Also DE is equals to DF. Sorry, DE is equals to EF. Construction. This is what we constructed. So you can say that therefore DE is half of DF. But DF is equals to BC. Why? Opposite sides of parallelogram. Opposite sides of parallelogram. So in place of DF, I can write BC. So DE is half of BC. So you can see over here in 7, DE is parallel to BC, and in 8, DE is half of BC. Therefore, from 7 and 8, line segment joining midpoints of two sides of a triangle are parallel to third side and is half of third side. And here we prove